This is an NBT4 lesson, development concepts, just figuring out how would you teach the lesson NBT4, how do I teach it, and what part should we get these kids to come across. The point of NBT4 is to get them to add and subtract using the algorithm, but also playing on their place value understanding. We just spent all that time getting them to understand place value. We're not just going to go away from it. I know that sounds weird. You're like, duh. But you're going to find out. As I show you, you're going to be like, oh, dang, I had actually taken out the place value aspect. Don't take that out. Okay, so on the board, I have written down our place value chart because we want to keep that. But I also wrote down the normal kind of way you've seen the adding take place. This is how we've seen it. I'm adding this. Now, why? The reason I'm doing it is because I want them to actually do the algorithm, but over here. So they're understanding, what do you mean when I'm carrying a 1? Or when you get to subtraction, what do you mean by when you're borrowing or stealing? What does that actually mean? We're going to actually show them over here and then have them do it over here. So they're actually going to do it twice, but getting that concept development going. So it's kind of a bonus reps in there. So in one color, I'm going to use red for this example. I'm going to do this first color. I'll even underline it in red so that we can see that one's going in there. We got a 1. We got a 5. 1, 2, 3, 4, 5. We got a 4. 1, 2, 3, 4. We got 2. And we got 2. Now I'm going to put a giant plus sign in here so we understand that we are adding these together. And then I'm going to do purple. Again, I'll put a line on here just so we can know that. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, and a 1. Some of you might start seeing the benefit of this. What we're used to doing, just in our age and how our teachers taught us, is go 4 plus 1 equals 5. That wasn't hard for us, and I don't think you've ever seen a student that that's hard for. They can do that, whether it's counting with their fingers, with manipulatives, whatever it is. Same thing with this. 1, 2, 3, 4, 5. We're just going to count the dots. That was easy. This is the part you may have already seen. Either you made mistakes with it, you've seen kids make mistakes with it, whatever it is, it starts to become this is the part that's hard. 9 plus 5, what you and I have done in the past is we put a 1 and we put a 4. Now, some of your students will understand what this 1 is, but not all of them. You're going to remind them back to the place value chart. Let's count a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now watch what I do. I'm going to draw that circle and put an arrow and add a dot over there. And we're going to have a conversation about that. What does that mean again? And they're going to remind you like, oh yeah, NBT1, when we draw that up, that actually becomes a tens place. That actually becomes a tens place. And that's just further driving home that idea. That is what that 1 means. Don't just say carry the 1. We're actually doing 10 times the tens to get another hundreds place. I'm going to leave that there, but cross it out so nobody gets distracted. How many tens are there? 1, 2, 3, 4. See, it's still following along. We're not getting the answer wrong or nothing like that. Now we go to hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to draw that circle again and put it over here. We're going to talk about it. If we had done it normally, how we were taught, 1 plus 4 is 5. 5 plus 5 is 10. We carried the 1. We put it as a 0. Are there any left? No, we put a 0 there, and we just go to the next number. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. Again, the natural way, the more way we've done the algorithm way. 1 plus 2 is 3. 3 plus 4 is 7. 2 plus 1 is 3. I always make them put the parenthesis there just for now. On the test, they do not have to put it. And so I suggest to the kids, don't ever put it on a test, because if they put it in the wrong spot, they're incorrect. But if they don't put it at all, it works. So be careful with that comma there, but it always is good to teach them that aspect. But this is kind of the adding way. Let's show them with the place value. Let's show them with the algorithm. Let's use the place value to further drive home why we're doing these things. So as we get to those big numbers and we're multiplying and all those other things, we can get that. Okay, now let's try that same thing, but with subtraction. Again, we're only using this to drive the point of why. When we're saying borrowing, when we're saying stealing, when we're saying ask your neighbor, whatever it is, the terms you use to steal from him, to help him. Let's use this to further drive it home so kids don't have those misconceptions that are always led in subtraction. I promise if you take the time to put this part in there to create that development, this part, you'll save a lot of time later. So let's use this to drive home this idea. Okay, how would we do that? Go over here. Let's just start on this side so we're not confused. 1 minus 4. The reason I want this, and it's visual, is because a lot of kids will put 3 here. You've seen it, I've seen it, we've all seen it, it's a normal concept. But when we're doing this, you can't cross out just these ones because these 3 guys are all left alone. We're getting rid of them. This is a subtraction problem. So that's when we teach them. We're going to actually steal from this guy. Now, again, go back to that place value in BT1. How many was this circle based on these? It was 10. So we actually get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we can go and cross them out. And we say, hey, this guy takes out that guy, this guy takes out that guy takes out that guy, and that guy takes out that guy. And now we can do our normal math thing that's easy. 1, 2, 3, 4, 5, 6, and 7. In case you don't believe me, let's go check over here. How did we do this? This guy tries to rob this guy, it doesn't work, so he comes and asks for help. He says, sure, I'll help you out. He becomes 4 because he gave away some of his. 1, 2, 3, 4. And he becomes in 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So instead of just having these numbers up here that most of our kids get, but there's still those occasional, like, what the heck's happening up there? They're really getting it driven home of, oh, that's why there's an 11. That's why there's a 4. Let's keep going. We can't take out that guy. 1, 2, 3, 4. We don't have enough, so we're going to do that same thing. We're going to say, hey, come and help me. And these guys become 10 more. 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we can start the process of him, 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 him. Him, 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 him. And then we do the normal 1, 2, 3, 4, 5. Let's go to this one. We have 3 up here. We have 5 down here. The numbers aren't the same, and my bottom number is bigger. So let's go cross out this guy and add 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and continue. 1, 1, 1, 1, 1, 1, 1, 1, 1, and 1. 1, 2, 3, 4, 5, 6, 7, 8. Again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Boom, 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 boom. 1, 2, 3, 4, 5, 6, 7. And 1 minus 1 is 0. Do you have to put that there? No. Okay, now let's just make sure everything worked out. We have 7. We borrow. We get 5. We borrow. We get 8. 13 minus 8. We borrow. We get 7 and 0. 7, 8, 5, 7. 7, 8, 5, 7. What I really like about doing it this way, it takes forever, and your kids are going to get really annoyed with you. But if you can make them do it at least once per lesson or per question, it's really going to drive that idea. There's 10 of these for these. For every one of these, there's 10 of these. For every one of these, there's 10 of these. And you're really going to drive home that place value aspect. Once they understand place value, everything else becomes easier. So use this to get to that, and you'll really get it. But that's MT4. Start it off. Get that going.